Dear civil engineers, in this lecture, I'm just going to show that how we'll design a combined footing. So in our previous lecture, I have just shown you that how we'll design a extra footing. So in this lecture, I'm just going to show that how we'll use or how we'll design our combined footing. So when we'll design actual combined footing, first of all, we go for a single footing and then we go for extra footing by connecting two single footing by a beam. So if is it okay, then okay, otherwise we is to go for the next process, for combined footing step. To do that, I'll just modify that one, and I'll request you, if you need to know about that process, how we can define materials properties, section properties, etc., then I'll request you, please watch our previous lecture. This link are given in description. So here, first of all, our column and the column we have assigned in both sides that are same. So what I'll do, I'll just delete everything. I'll delete everything. Okay, I'll take a new model. I'll click here and then I'll go for no step change, and here I'll use that one, this built-in option, and from here I'll select our required code, and here display unit, everything here. Then I'll go for next, and from here for footing I just need a two grid for combined footing. So in x direction I'll take 2 grid, and y direction I'll take 1 grid, and in x direction I'll take the distance between two columns. I'll consider that is okay, 10 feet. I'll consider the distance between two columns are 10 feet. And here for spacing of y direction, this is not necessary to change, and here you can change, or if you think that nothing to do here. So I'll just click here grid only, then I'll click OK. Now when I'm here, I'll just go for our next step. Now I'll just go define materials properties. So here already our previous lecture, especially in our first lecture, I've shown you that how we'll define that materials properties and everything. So I'll request to please also that video first, and here I'll use that 44,000 psi concrete, and here 60 grade steel I'll use to design that, which are default here. So I'll just go OK, and from the section properties I'll just go for slab section, and from here I'll delete that one, and I'll go for add new properties. I'll just give her footing. I'll just give its name footing, and from here I'll select our slab materials. This is 4000 psi concrete materials, and from here also I'll select footing, and I'll consider our footing thickness are 15 inch. So everything is okay. I'll just go OK, and I'll delete that on. And after defining our footing, we have to define our column stiff. So from here I'll just go add new properties. I'll say column is stiff, and from here I'll select I'll select from here is stiff, and from here I'll take 15 inch. And you have to remember that, or you have to understand that your column is stiff and your footing size should be same, footing thickness should be same, otherwise your punching shear value will not be displayed. So I'll click OK, then I'll click OK, and after that when everything is okay, and I'll go for our spring property, and you know that we will provide area spring properties. From here I'll just give here bearing capacity like that. So what will be the subgrade modulus? So for subgrade modulus, I will use a Excel sheet I have created for myself. So maybe here soil subgrade here, soil subgrade modulus. So for that data, okay, I just have to use our allowable bearing pressure, then factor of safety, and after that I have to apply allowable settlement in foundation. Okay, so for allowable settlement here, you can see that the allowable bearing pressure, you have to provide here allowable bearing pressure as per your soil test report. So I am providing here 2 TSF, and where factor of safety, what will be the factor of safety? It's depend on your code. Okay, so your code will discuss, or your code will permit a factor of safety. So as per my code, this is 3, and here allowable settlement for footing. What will be that allowable settlement? You have to provide here, and after providing that data, just see I'm just giving here allowable settlement are 25 millimeter, and here factor of safety are 3, and also allowable bearing pressure are 2 tsf. After that, just see here are the value of k in lb per feet cube, but we need in inch, keep inch cube. So here just see keep inch by inch, so inch cube. So what I'll do, I'll just copy that value and I'll paste anywhere as a values, and after that I'll copy it and I'll go here, just here. Actually, what is that value actually? Okay, so this is nothing but the allowable ultimate bearing pressure, ultimate bearing capacity of soil divided by allowable settlement. So it's nothing but without that two values. So when it's done, I'll just go for okay, and then okay. So when it's okay, then I'll go define. After that, I'll just go for load pattern, and here I'll use only dead load and live load to design our structure. So for dead load is already defined, and also I've shown in your previous lecture that how we can do that. Then okay, and after that I have to just go for load combination. So what will be the load combination? I'll take combo 1 for 100% dead load and for 100% live load, or skill factor 1 on for dead load and live load. Then okay, actually you can change that load combination. A detailed video have been created previously. I will request you to watch that. So after that, okay, so we have completed defining everything. Now I will draw our slab section. So to draw our slab section, I'll take 3 points with respect to that data. I'll just go here plan, and with respect to our with respect to that data, we'll go for our foundation. So from here I'll just go draw, then draw joint object. From here draw joint object in in y. I'll take 2 point. Actually here in that point and that point I'll take 2 columns. So I'll take a footing like here in -x, so 2 feet, and in y 3 feet. Okay, I'll take that is as 1.5. This is the value, so I'll click here, and after that minus y, I'll take another point here, and in here for positive x and negative y, here I'll take a point, and in that side I'll take another point, so that will be positive x and positive y. After that I'll take another point here. Just see points are not showing, just I have to click here view, and I'll refresh windows. Okay, I'll just click here for refreshing our windows, and if okay, now here the points we have assigned that are available here now. So actually I have done a mistake here actually. So what is the mistake? I have defined that value as a feet, but we have to define that value as a inch. So I'll skip that value, and I'll select every point. I'll delete from here. Now again I'll go for draw, then draw joint object. I'll click here to draw our joint object. So click here, draw joint object, and from here I'll draw our joint. So in y direction, I'll take 2 feet, okay. So or 2.5 feet, so it is 30 inch in y direction a point, and in opposite x from here in that direction x. So what will be that value? I'll consider that value will be 24 or 18. Okay, so that will be okay. So 18, and now I'll click here. I'll take that value as a minus value, then here, so 1 point. Okay, if I just go plan view, just see here the pointer available. Again I'll go draw joint object, and here in x minus 18 inch, and in Y minus 30 inch. Enter, and I'll just click here, and for that side I'll just go positive 18 here, and also Y will be positive for that point. And if I just go for our click here for plan view, just see here 4 points are available now. Now I'll draw our slab first. So to draw a slab, I will use that rectangular floor option, and from here I will select our footing, and after that I will click here. You see, so here we have created our footing. Now after creating our footing, I will use that option, quick draw area around the point. So I will select rectangular portion, and from here I will select column strip. And what will be our column? I will consider 12 inch into 12 inch. You can change that as per your requirement. So I'll click 12 inch into 12 inch. So here this is our one column, and I'll click here, and this is our another column. So after that, what we have to do, I'll select our footing, and after that what we'll do, actually I'll go for our assigning, just go shell, and from here area spring, and from here BC, and apply. So we have provided BC here. Okay, our spring value BC, bearing capacity have provided. Now we'll provide load. So as our two columns are same, and I'll consider the load on two columns will be same. I'll provide two load on two columns are same. So otherwise difference, so I'll select. Okay, just see here, if I click here, there no points are selecting on shell are selecting. So what I have to do, I have to go ahead, draw joint object, and it should be 0 0, and after that I'll click here, and I'll click here. Now if I click here, just see a point have been selected, because we know that we'll provide our column load or footing load as a point load. Now I'll go assign, then I'll click here the joint load. So here force, here first of all dead load. So what will be dead load? I'll consider our global Z. So what will be the value of our global Z direction? So that will be minus suppose minus 40 kip. Okay, so minus 40 kip. And if you want to provide moment as per your requirement, so if I provide moment, suppose 5 kip moment, and for Y suppose minus 10, like that. So when it's done, and the most important thing, size of the punching shear. So what will be the size of punching shear? That will be same as your column size. So as my column size are 12 inch into 12 inch, so you have to in X direction 12 and also Y direction 12. After that I'll click apply. The load have been applied it. I'll click here, pre-select here, pre-select our point have been selected, and from here I'll change live load, and I'll consider our live load will be suppose 55 keep, and here I'll consider our moment will be 10 in X direction and Y direction 2. I will just consider randomly. So this is okay, 12 inch into 12 inch, and replace with the existing load. That click apply. Now I'll select that point, and after that okay, I'll assign same load as a live load here, and again I'll click here, and for dead load, suppose I'll assign as a dead load okay 45, and mx I'll consider 13, and my okay, let's 8. Okay, I'm just taking random value here to see you. Just okay, just see load we have applied it, and if we want to see, I'll just go for apply. Okay, oh, sorry, I have done a mistake here. Just see here the load are seeing this is in up direction, but here this is in down direction for live load. Again, if I just go for the point load, for this is, if we see for dead load, so this is okay for dead load, but in that side they have no dead load actually. And also if I just go for live load, and here just see the live load are available, but our the value of I mean upward value are showing, I mean our downward value are showing in upward direction, so we have to change that. And if I just go for dead load, then force, and here in that side the value of force are not showing, so I'll close. I'll just select that point. I'll go for assign, Again I'll go force, and from here that was plus, that will be minus. Okay, just see now it's okay. Again I'll click here for pre-select and I will assign dead load. So what I will assign as a dead load, so suppose 50, and I'll consider that is just 12, and that is minus suppose 9. Okay, then apply. Oh, sorry, again I have just provided here a plus value, so I'll click here apply. Just see, okay, no object have been selected. I'll click pre-select and I'll click apply. Just see now it's okay. Now I'll close and I'll go for analysis. Done. Now we'll go for analysis. I'll click here, run our model. I'll select combined footing version 20. I'm just giving it a random name, and here just wait for some time. It's analyzing our model. Okay, I'll ignore that one. Ignore also that one. So just see here our the value of the displacement for dead load are showing. So what I'll do, actually I'll just go for here I'll go for deform shape, and from here for combination I'll for combo 1 I'll check that automatic, and then everything is okay. I'll just go apply. And here if I just click what's our allowable displacement, that was our allowable displacement was 1 inch almost. Okay, so here our allowable displacement was 22, and this is in millimeter in inch 0.98. So but here we're seeing that this is very less, so this is very less really. So what we can do, we can go for minimizing our thickness, and okay, it's done. I'll change that if required in next. Then again I'll just go here for our soil pressure, sorry, not that one. Here our soil pressure, display soil pressure. So for combo 1 I'll go for soil pressure and show values. Here I'll click here show values on show lines if required. So it's okay. After that I'll click apply. So just see in that side showing value 3 4 5 6, and here this is 3 4 something, and here 3, and here 3904. So what is our allowable value? So here we're seeing our allowable value is I mean allowable soil pressure is 4404, but here our maximum value, if I just take our mouse here, 4002, that means our foundation is absolutely okay. Now I'll go for another check. I'll just go for display, then show punching shear design, and here in that side we're seeing that this is 0.92 and 0.904. that means we're not able to decrease our slab thickness anymore, because already it's better if we increase little bit our slab thickness. Okay, so we're seeing that our all take are okay. Now after that we'll go for our next step. So what will be our next step? I'll just unlock that. We'll go for design. So before design I will just assign strip here. So for that I will use that on design strip. So from here actually they have no use in a design strip, I think so, but if you want to design as a design strip, then you can go for that. And here width, so what will be width? I'll consider for 2 feet 2 feet. So for here 2 feet means 24 inch, 24 inch, and every side 24, and here 24, and here the strip in layer, the strip layer A. So okay, for A I'll take our strip layer from that direction. I mean I'll consider from here, or I'll take from here, and after that I'll just change it. So I'll click here, I'll skip, and after that I'll click here, I'll remodify that. I'll just move here. Just see this is the value of our column strip. Then I'll skip, and again I'll go for direction B. So here this is already selected, and just I'll only change that value of B. So it's not okay, it's selecting. So from that point to that point here, I'll take your value, and again from that point to that point. Okay, and from our middle, so it's not showing us a middle step. So for that, I'll just go draw, then snap option, and I will just go here for line its and midpoint. Okay, so I'll just go apply, then its, okay, then okay. So when I'm here, just see here's the midpoint. Simply, oh okay, I just have to change something. So I'll just click here, and from here, this is not column strip, this is middle strip, right? So from here, this is the middle point area, and I'll go for that. Okay, so here are midpoint also, then skip. So we have perfectly defined our strip. Okay, now we'll go for analysis. I'll just ignore that. Okay. So if now go for that option, so display team, oh sorry, display that option, display strip force. So I'll just go here for combo 1, and for moment I'll just click apply. Just see, this is the value for our moment, and so value also. So here's the value of moment. Then if we go for our share, so the value of share, then for torsion, and then for axial force. And if we go for layer B, then apply, sorry, go for moment. Just see, the moment here are showing in three layers. Okay, moments are showing here in 3 layers. Then for shear force, it's showing shear force, and for torsion, it's showing torsion. So when it's done, now I'll go for our design. Okay, so display, then show slab design. I'll just click here, show slab design, and first of all I'll go for strip based design, and for impose minimum load, show top river and bottom river layer A. For layer A, I'll just move it, and here everything is okay, and I'll just apply. Now it's showing us how much reinforcement we record. Actually, it's showing us, so in top here we record in top reinforcement, and here we record in bottom reinforcement, and also here uh, in layer A, we do not record any bottom reinforcement here. Just see, but here we record bottom reinforcement and also top reinforcement. We're seeing that, but here the record much more bottom reinforcement. Now here everything is okay, and after that I'll just go here for layer B, then apply. Just see here the reinforcement requirement are showing very much. So this is for bottom, and that side record more top reinforcement in outer side, but in downside we record more. Let's see here we record the reinforcement requirement are here. So what we can go for, this is actually area per unit width, area per reinforcement are showing area per unit width. Okay, so I always prefer that option, typical uniform reinforcement. So if I just go here, and for top I have selected number 5 bar and with 12-inch spacing. Just see in that direction. Okay, for our layer A. Okay, so for our layer A, the value, sorry, for our layer B, it's showing the reinforcement requirement. Just see here, it's showing reinforcement requirement. So here we have provided number 5 bar, and also here we record some bars. So I'll go for number 5, 8. So here also we record some, then I'll go for 7, then I'll go for 6, apply. So if we provide the number 5 bar in 6-inch spacing, then it's okay. And for our bottom river, if I directly go for 6, then it's okay. And if I directly go for 7, then it's actually for bottom we record 6-inch also, 6-inch spacing. So in top and bottom both in that direction 6-inch. After we have to provide reinforcement after 6-inch direction. And for layer B, I'll go for this is okay with 6-inch for layer B, so I'll go for top. In 8-inch. This is actually we record little bit reinforcement in middle strip. Okay, so here we got some reinforcement in middle strip here also, but if we just go for our bottom reinforcement, so there are no requirement of bottom reinforcement in a direction with 6 inches spacing. If I just go for 6, done. Then if I just go for bottom, if I go for 8 inch, so it's okay with 8 inch. Then if we just go for 10 inch, then it's also okay. So in this way you are able to design your slab perfectly without any problem. Then I'll go close that, right? So this is the way to design a comment footing. In this way you are able to design your comment footing actually. So thank you very much, and if you think that that's helpful for you, please subscribe to our channel, and also support us by joining our channel or support us by giving us super thanks. Thank you very much. Well, stay connected till next video.